So we have the standard deviation of y then is 0.843. So what we're interested in is a variable t, which is going to be the total number of finals that a student takes. And we want to find the mean number of total finals and the standard deviation for the total number of finals. So the mean of t is going to be equal to the mean of x plus y, since t is just x plus y, right? We're adding the two together. So if I follow that formula, that's just the mean of x plus the mean of y, or filling in the numbers here, 1.95 plus 1.3, which is 3.25. The standard deviation of t then is going to be equal to the square root of the variance of x plus the variance of y. So I'm just following this formula here, and I'm just putting a big square root over it because I want the standard deviation in the end. So filling in what those values are, this is the square root of 0.865 squared plus 0.843 squared. So altogether that gives us 1.208. Alright, so going off of this problem then, we're given that final exams take 3 hours to complete. And final papers take 4 hours to complete. We're going to then let H be the total amount of time spent on finals. So we want to find the mean amount of time spent on finals and the standard deviation for the total amount of time spent on finals. So for the mean of H, H is really, maybe we should back up here, H is really 3 times however many finals the student has to complete, so 3 times x, plus 4 times however many final papers they have to write. So the mean of H is going to have to be a combination of these two formulas for means, because I have a value that I'm multiplying each of them by. So the way we combine that is just going to be 3 times the mean of x plus 4 times the mean of y. So we're just combining those two formulas together. So this is 3 times 1.95 plus 4 times 1.3. So total number of time they can expect to spend on finals is 11.05 hours. The standard deviation then, so of course that's not going to be the same for each student, so we want to know how much it varies by. So this is combining those formulas again. So the standard deviation of 3x plus 4y. We need a square root over that to get the standard deviation. So I know that my b value for my x would be 3, so I need 3 squared times the standard deviation for x squared. So again, combining those two formulas. And then the same thing for y. So that gives us a standard deviation of 4.255 hours. All right, so we're ready for a check here. So you guys are going to try page 376, numbers 1 through 3. So pause the video, go over and try those, and come back and see how you did. All right, so let's see how you did. So we have T, which is two random variables here, X and Y added together. X is number of cars sold, Y is number of cars leased, and then they give us the mean and standard deviation each for X and Y. So they want us to find and interpret the mean of T. Number 1. So the mean of T, I hope we all got, is just the mean of X plus the mean of Y, which would just be 1.8. So when you interpret this then, when you're interpreting a mean, you want to make sure you talk about it being in the long term or over many Fridays, since this is just referring to Friday sales. So over many Fridays, the dealer sells or leases, because it's a combination of them, about 1.8 cars in the first hour of business on average. Okay, let's go ahead and compute the standard deviation then for number 2. So the standard deviation of T is going to be the square root of the standard deviation squared of X plus the standard deviation squared of Y, which is just 1.2988. Or excuse me, the square root of 1.2988, which is 1.14. The last one then, so talking about a bonus, the bonus, or the manager receives a $500 bonus for cars, so $500 for X, $300 bonus for cars leased, so $300 is for Y. So we want the mean and standard deviation for the total bonus. So the total bonus, which they are calling, I don't think they give us a letter, so we'll just say B here, is going to be 500X plus 300Y. So this is like what we looked at with the final exams. So the mean of B is just going to be 500 times the mean of X plus 300 times the mean of Y, which ends up being $760. All right, when we're doing the standard deviation of B then, that's going to be a big giant square root over 500 squared times the variance of X plus 300 squared times the variance of Y, which ends up being $509.09. Okay, so this whole section is really about taking those formulas and manipulating them to represent whatever your situation is representing.